Hello and welcome to this video where we're going to code the iconic snake, which is so beautiful. I love the mechanic of snake, and we're going to get that key mechanic of the game program now. So last video, before we get to this beautiful diagram, let's have a look at what happened in the last video. So this video, what I'm doing right now, I'm going to show you the main mechanic, so you could just start here. But if you wanted to know how to set up what we've got so far, a moving block on the screen, I'm using the arrow keys and I'm using the P5 library linked to JavaScript. If you want to learn how to just set up the basics, go to the previous video. But if you can handle that much on your own, you can start here fine. All I've got is a rectangle moving around on the screen using the key is down keyword, which is part of P5. So you could have a look at the previous video to see exactly how I've done it, and I've done it literally from scratch. Just a few functions where we set up. We've got the main game loop here, the draw loop, so that goes round and round and round and round. So that's where we're redrawing the background, checking for input, we draw the snake and move the snake. So, diagram. What happens? So far we've just got segment 1. We've just got this this segment here where we can move it around, but we want to add other segments. And when we hit an object, like eating an apple, I think it was an apple in Snake, or was it a number, something like that. When you hit that, then a new segment gets added. Where does it get added? At the back of the snake. So it'll be something like, I'm just thinking about pseudo coding it now. If we're moving left, we want to place that segment kind of like 1, 2, 3, or measure the length of how many, or count how many segments we've got, times the width of our segment along the x-axis. If we're moving the opposite direction, then it's going to be the same calculation but minus direction. Then if we're moving down, it's going to apply to the y-axis. So that's where we're going to place a segment, but we need to be using arrays, and we need to loop over those arrays of segments. So Snake is a classic game for showing you how to use arrays. So the first thing we need to make is an array. I've already made my note there. We need to change our hard-coded x and y, which just control and organize a single segment, into an array kind of structure. So let's just have a look at what else we might need to change. We don't need to change anything in setup. There's no mention of x and y, nothing in the draw loop itself. But in draw snake, where we're drawing our rectangle, we refer to x and y. Now, we could have an array of x positions and an array of y positions, but it would be difficult to kind of refer to two different arrays at the same time and draw that snake. So let's do what we did for the movement, the direction. We made a vector. We just said we want this one variable, but that variable stores two things in it, an x direction and a y direction. Well, let's do exactly the same for the x and the y position. So in setup snake, we'll stay down here. Instead of saying the snake's position is here, we're now going to refer to like segments. So we're going to say something like, we'll call it pos for position. Position equals create vector, and we need to put these positions, position is not going to be a vector. It's going to be an array that stores lots of vectors in. So let's make pos a global variable. And what kind of variable? It's going to be an array. So to make an array, you say equals and then use the square brackets. So essentially, we're going to put things into pos. And we're going to put not lots of x and y's, but we're going to put, don't need these guys anymore, we're going to put vector objects into them. So I was getting mixed up down here. So pos already equals an array, we want to say let x equal width divided by 2, let y equal height divided by 2. So let, if you didn't realize, is now a keyword introduced by the ES6 standard, or it's also called the 2015 standard for JavaScript. So that's so lots of significant improvements, I would say, and progress was made in this ES6 standard. One of which was the let keyword. So you can use let wherever you would use var, but let has temporary scope within, what's it called? Like block scope, I think it's called, something like that. So if we created let, sorry, I won't go into this. I might have the details wrong anyway, but if you're using a temporary variable, you don't want to use it for much longer, you can use let instead of var. Anyway, so I just want these two temporary variables, and I'm going to put those into a vector. So I'm going to say let pos vector equal create vector, and I'm going to say x and y. There we go. So I could have done this all with one step. I could have just put width divided by 2 into here. Shall I just do that? Control X. Let's just do that. Width divided by 2. And I think I'm quicker typing than I am copying and pasting. Height divided by 2. There we go. So we're just making a temporary vector, and we're going to put that vector into the first position in our array, which is called pos. And we do that by saying pos.push. Now, you can put .push when your variable is an array. It has this function, and that just means put on to the end of the array whatever is in these brackets. And we're going to put the pos v vector into there. There we go. So this vector now, this array called pos for position has a length of 1. But let's just have a look at our diagram. I've also put some numbers on these segments to represent an array. You can think of it as the snake's actual body, but also the kind of the abstract data structure that is managing it behind the scenes. Your first container in an array isn't indexed with the number 1. It's indexed with 0. So if you've got an array of, let's say, 3 vectors, 3 positions, 3 segments, you've got an array of a length of 1, 2, 3. But the first segment in there, the head of our snake, is going to be referenced by 0. So let's keep that in mind as we continue. So we've got a position on there, and that position is in the middle of the screen. Okay. Let's draw our segments. Where was draw? Draw snake. So x and y don't exist anymore. What does exist is position dot x, position dot y. But we haven't told it which, where's the diagram, which segment in the array to talk about, which x and y. Is it your x or is it your x? At the moment, we're trying to point to an x and a y that doesn't... Position itself is just an array, it's just a container. It doesn't have an x and a y. The objects that we've put inside of it, they have an x and a y. So we don't know how many x and y's we're going to have. So we need a for loop that refers to the length of that array. So we're going to say for let I equal 0. We're going to start at 0, and we're going to go around while I is less than the length of pos. So we use .push to put a new object onto an array. Now we're going to put .length. That simply returns how many segments, or sorry, how many things we're storing in our array. And we don't have to put length minus 1 because I will only go up to the length minus 1 because I has to be less than the length. So if we've got a length of 3, 1, 2, 3, I will only equal 0, 1, and 2 as we're going around this loop. This will make crystal clear sense in a moment as you see the for loop being constructed. So we're now saying I gets bigger every time we go around the loop. So first I is going to be 0, then it's going to be 1, then it's going to be 2, then it's going to be 3, and then it keeps going until it gets to the length of the position minus 1. It's not going to get to that full length. So how do you refer to each position in the array? You use the square brackets again, immediately after the name of your array, and then a number. And I'm going to put in this variable because I want to loop around. I'm going to change, I'm going to vary that value every time we go around. And I missed. There we go, right. So we're going to refer to position, sorry, the first vector in there. That's going to be at the 0 segment. Then it'll loop around. Then we're at the first position, sorry, the index 1 position, index 2 position, and so on. So we're going to iterate over these positions in our array. Okay. This should work. This should already work. Except for movement. I think I have to move. Right. So, this is a complicated bit. What do we want to say here? Let's have a look at the diagram. We want to say, starting at the last segment. So we want to find the last segment. So that's going to be the length of pos minus 1. Because the length of pos in this diagram is 1, 2, 3. It's got 3 objects, 3 segments in the array. But the index number, how do we refer to this one? It's called 2. So it's going to be the length of the array minus 1. Okay, we want to grab u, and then we want to say u move to the segment before u, move to its position. And then when we loop round, we want to say this segment now. So we want to go backwards this time in our for loop. We want to go backwards. We want to say you move to that one. And then the head, once we get to 0, once I equals 0, we want to simply move you in the ordinary way. So when I equals 0, we want to say the x position simply moves where are we? Change move. Yeah, sorry, we're here. We want to have x plus equal movement. And movement can be still global. Okay, right, let's do this. So, similar thing, we're going to say for let I equal, and we want to start with pos length minus 1. Remember, we want to refer to I as 2, not 3. Okay, and if the snake was 100 long, the last segment would be 99 because we begin counting from 0. That should make sense. So we're going to say while I is greater than, should we say greater than 0? And then what we could do is we could worry about the 0 segment down here. The last thing we want to do is basically say position 0 dot x plus equals s movement x. So we're basically just doing exactly as we were doing before, but only for the head of the snake, only that one segment. So we could do that down here, but for all of the other segments, we're basically going to say follow the person in front of you. Go to the place where the person in front of you is. Right, let's do that. So we're going to say pos. Let's get our indenting sorted out. Pos I dot x equals, and you're going to be the position of I minus 1 dot x. And I've just spotted, I'm getting ahead of myself, I haven't finished my for loop yet. So, and we're going to say not I++, we're not going to get one bigger, but we're going to decrement. We're going to go in the previous direction. And then, have I opened my for loop? I think I've closed it somehow. There we go, I've closed it. And I've opened it. Okay, everything's okay. Right. So, yeah, what have I just done? I've said, your position, so this is going to now be, we're going to start as I as the last segment, and we're going to say you last segment X position become the position of the previous segment. So we're not going to change the previous segment, we're just going to refer to it, which works well. Working backwards through the array is working well so far. And all we need to do then is do exactly the same for the I component, sorry, the Y component. There we go. So that will iterate down the snake and move everything to where everything else was. I think this will run. So I've saved it. I hit our flashy icon in brackets and see if the local server will produce next. So good news so far. It's moving and I'm pressing up, down, right, left. Yeah, everything's moving. So we haven't derailed and destroyed what we had before, but we want to be able to add segments on. So should I do the collision detection or just have a way of adding segments when I want to? Let's let's just add on segments when I want to. Right, and then I might finish the video there. I've got a feeling I've let this go on. I haven't looked at when I started again. So we'll say function mouse pressed. So this is a P5 function. Every time you press the mouse or touch the screen, I believe, this function will be called through P5. Again, if you're interested in knowing how to set up P5, see the previous video where I go through how to do that. So mouse pressed, I'm going to say new segment. Let's write a function to do that. New segment. And then if we need to create a new segment somewhere else, we'll be in good shape. We can just call this function if it works. Okay, I think I talked about, did I talk about this at the start of the video when I said if we're moving in this direction, going left, we don't want to put the segment, we don't need to refer to the Y axis, we just need to calculate how many segments we've got times the width of each segment and put it on the back. And if we go in the other direction, we do the same calculation but then minus that distance, and then equivalently for the y-axis. So let's say, can I just do it up? Let me just think. Can I just refer to the vector, the direction vector? Yeah, let's just try and write it. Let's just, what does Dan Schiffman call it? Kind of like a stream of consciousness coding. Let's just try. So so we're gonna make a new like X position, Y position, and then oh yeah, we need to add this new position onto the position array. So I'll call it new X equals, and we're gonna say position 0. So this is the head of the snake's X position times the length of position. Do I need that plus 1? Minus 1? Let's see. So let's say I'm adding one new segment on. So at the moment, let's say X is 10. Say 1, 2, 3, 4, 5, 10. It's about here. So at the moment, the movement is minus. But I want to go plus. Let's write it a different way. Or can I just Do I want to square it? No. Oh, I just need to negate it. I can just negate it. Yeah. So I'm going to say, I'm going to negate the movement. So if it's a minus, it's going to become a plus, and if it's a plus, it'll be a minus. So the position length, x is going to be, so nx, our new x position, is going to be the current position of the head times the length, so that's the number of segments we've got. Yes, this is working. Times the size of our snake. Let's just put in a snake size, S size, and we'll drop that in here where we're drawing our snake. So if we want to change the size of our snake later on, we can do it nice and tidily in a global variable. S size equals 10. S size, you know what, I'll put that value in, that default value, when we set up our snake, which is here. S size equals, let's make it bigger now, let's go 20. So we've quadrupled the size, doubled the size. Right. Okay, so what we're doing, so the x position times the length, the number of segments, times the size of each segment. Might want to do half of that size. I can't think. That's it. I think that's it. And I wanted to minus it. What do I want to minus? Oh, sorry. We don't know what direction we're going in. Times S movement. That's the direction vector. And we just want to refer to the x component. And this is the bit that we want to minus. So if it's 0, if we're just moving up and down, this is going to be 0. Even if we've minus it is 0. So all of this gets zeroed. So we're not changing the x position, which is brilliant. If we're moving up or down, the x position wants to be exactly what this position is. So actually we need to say it's this position plus all of this. There we go. That makes more sense. Right. Then we just want to do the equivalent for the y. Position length times the size and minus the y. Is that right? If we are going up, we want to be plus, yes. So the current movement will be minus, so we want to minus that minus, so it becomes a plus. So we're drawing our new segment, or placing our new segment, and then drawing it further down the snake's body. Right, so we can add new segments when we click. Let's just see if this is going to work. Something should happen. So we've got a larger snake, and I click, and nothing's happening. Nothing's happening now. So either we're drawing the snake segment far too far away, or there's another bug, which I'm just bringing up the console now, can tell us about. Or maybe I didn't save it. Ah, here we go. 5 icon. No, these are not problems. With my code, right. Let's just have a look. Right. So we make a canvas, we paint the background, we put it in rect mode center, so I'm drawing from the center of rectangles, and then I set up my snake. So what do we do? Ah, we're not pushing a new position. Sorry, we've calculated that. I've worked out what's going on. I'm not actually doing anything. I've made a new segment where I've found a location and I've put it in a temporary variable. I haven't pushed that new. I haven't even made a vector to then push onto the snake segment position array. So first we need to make a new vector. We'll call it nv equals create vector, and we want to say new x, which we've just calculated, and the new y. And then we want to say position, could you push that onto your array? and we're going to push on NV. There we go. So I've saved that. I've hit our favorite lightning bolt icon, and our snake's still moving. Let's see if I can click him. Yes. Ooh. When I'm clicking, things are being added, and we have got a classic snake movement, but it's clearly gone wrong. Oh, wait a minute. No, it's kind of going right. The last segment's being added, and it's being added in the right place, i.e., if I'm moving up, the white square you see is being put on the in the Y direction at the end of our snake, and the same for the X position. So I'm just not doing it far enough. So let's have a look. The X position would be wherever X is, the head of the snake, plus the length. The length at the moment is 1. Plus 1 times the size, 1 times 20, times minus the movement. It's going to be 1, minus 1. So it should be 20 away. Let's double that. Is that the problem? Actually, there's definitely an error there. That really doesn't seem right. That's very mysterious. Let's see. Adding. So I want X to be the current head of the snake's X position plus. So I'm saying 1, 2, 3, 4, 5. 5 times its size. Have I got that right? Var size. Size equals 20. Times 2. X movement, Y movement. It'd be 20 times 1, 20 times 2. That should work. I'm really bamboozled. Interesting problem. Let's take out my random change. Here's a debugging tip. If your amendment to the code didn't solve it, take off what you just did. Else you're doubling up your bugs as you go. Pos length. It's not as simple as saying pos length. I'm really confused. Maybe it's not in the new segment function we've written. Maybe so. Again, I've just added a little change there, and it hasn't solved anything. X and Y. Don't think that's the problem. So the other thing, so the other thing that might be happening is it's not where we're calculating where the segment should be, but how we're calculating the movement. So what did I just change then? I just changed the name of it, so I can leave that. No, I'll take that off again. So so how we're drawing the snake seems to be fine. That's simple. We're just iterating over our segments. It's going to be in here. It's going to be in here. So x minus 1, y. Don't know how though. I'm going I equals pos length minus 1 of the last segment, while I is more than 0. So the last number I will be is 1. Let's just have a look at that. Pos 1 equals pos I minus 1. So equals where the head was, and the head minus me. So what this does is each segment will be placed, probably wrong, will be placed a significant distance away from the previous segment, but then this movement function basically squashes the snake up again. So it doesn't. So we need to move the snake by at least its size. Is that right? Times its size. So instead of moving by 1 or minus 1, it's going to be minus 1 or 1 times its size, which means our snake is now going to move very fast. So we might run into another problem. We might not be able to see him. Oh god. Let's slow that down. So what we could do, I'm sure I'm doing this in a terrible way. What else could we do? In the draw loop, I'm only going to move the snake, let's say every, I don't know, 100 frames or something. So if frame count modulo, where's my percentage? Modulo 100 equals 0, then move the snake. Okay, so the modulo operator, which is percentage, it says if the frame count divided by that number divides exactly, so there's no remainder, then you can move the snake. So this will only have no remainder. Frame count divided by this number will only have no remainder when every 100 frames. So let's just see if that slows it down. That will be 100 times slower. Is that correct? It's way too slow. Let's speed that up by a factor of 10. Okay, our snake is moving. So this doesn't satisfy me, this solution. But anyway, it's a solution. So if I click now, I've added a segment. Now it's working. There we go. So I can keep clicking, and it's calculating the segment to be in the correct place. Sorry, that was just an illusion. I was clicking at the same time as moving in the opposite direction. So it was working. Oh, I can go over myself. I was afraid to go over myself. There we go. But we haven't programmed that functionality yet. So to do that, can you think how you might do that? You might have, in the draw loop, you might you might loop over all of your segments and then check it against every other segment and say, are you in the same position? And if you are, game is over. That's how you might check that. So I'm very pleased with this. There we go. I'm not pleased with that solution though, of only every 10th frame move the snake. That's one way to get it going. So I think I'm going to leave it there. This video, I dread to find out how long this video was, but we had some nice debugging. We had a problem with our arrays, and the problem wasn't in the function I thought it was going to be, and then we looked at another function, which is a very realistic kind of a scenario. That's what it was real. That was that actually happened. So there you go. That's how to make Snake, and I love Snake. I love whoever invented this. I should have researched and planned and things and prepared, but whoever invented it, it's gorgeous. What a lovely idea, and what a brilliant way to teach arrays to future programmers. It looks like an array. It is an array. It's managed and organized through array. So there you go. Hopefully that was helpful. Do upload. I'd love to see your version if you make one. So that's how to do it in JavaScript using the P5 library. Have a lovely evening, or morning, or just have a nice evening and take the morning how it comes. So thanks very much.